And we are now live. Welcome to this Open Neuromorphic workshop. We are joined today by Gregor Lenz, who's one of the founders of Open Neuromorphic and has been doing excellent work for the entire community with his work in Tonic. I'll explain what that is in a second. I'll just first say that he has a lot of credentials. He's a Sorbonne PhD. He co-founded the neuromorphic startup Neurobus, and now he's a machine learning engineer at Paddington Robotics. So Gregor is a person with a ton of experience, really worth listening to. So Tonic has played a pivotal role in the community. It's been one of the main drivers for neuromorphic datasets, which is one of the most important aspects of any machine learning pipeline. And it's important not just because datasets are important, but the neuromorphic community works with data that's a little different than most static datasets that we know, like MNIST or CFAR. So there's been a lot of work into engineering the API and the different data transformations needed to not just encapsulate all these datasets, but also make them somewhat efficient so it doesn't take years to develop these things. So I'm very, very proud to welcome Gregor Lenz on stage. Gregor, thank you for talking today.
Thank you. Thanks for the invite, Jens. Just a quick note that I really appreciate also you taking over Open Neuromorphic and like putting a lot of effort into it. So thanks a lot for the invite. And yeah, I'm going to be talking about this library that originally, the original idea came up in 2019 at Telluride. Back then, we wanted to explore some augmentations, some transformations for event-based data, because we thought maybe, augmenting time steps makes it a bit more robust to, temporal fluctuations. That was maybe not so important in the end, but what was important, I think, was that we saw that there's a real need for standardized dataset formats, because there's so much, there's many different public event-based datasets out there, but they are not really accessible. Some of them are not very easily accessible, or just with very custom data loaders. So I then rewrote a bit this library during my PhD, and then when I went to work for SynSense, they also doubled down on it, and we really improved the library and made it faster and improved their documentation. And yeah, since I think 2023, it hasn't changed too much. I think the most of it is pretty stable. But I've seen people add pull requests with their own data sets now, so it started to get a bit of traction, and that was a sign that I saw that it is something that people wanted to use. So what problems does Tonic solve? So there's lots of different event camera file formats out there, because the market for event cameras is still new, and that's why it's very fragmented, and every manufacturer has their own camera format. And so that's why you need custom data loaders. And, people use NumPy, ROSBEX, DAT formats, EDAT. I have seen people use text files to store data sets. Not surprisingly, this is terrible when you try to read any events fast. So there's lots of, first of all, file formats, and then also different ways to represent them in your Python code, right? So there's SciPy and NumPy, and again, ROSBEX. And so the idea of Tonic was to kind of choose one format that is efficient. And so we went for a NumPy structured format, NumPy structured arrays, and fix data formats such as how does the time step look like, and so on. It's just Tonic provides this connector, this adapter between whatever dataset owners chose to encode, and just converts all of that into the same output format. so that users, researchers can, they don't have to tinker with how to convert data, because that's, the boring bit of data management. So most people want to do similar things, right? So they want to pick a public data set that they saw on a paper. They will want to maybe slice and dice it a bit, depending on, how many samples they want and which subset they want, and the representation they choose. And then they want to feed it to the model to train their machine learning algorithm. And hopefully that happens as fast as possible. Tonic is, in that sense, inspired by Torch vision. So Torch has several different domain-specific libraries. So Torch vision is for images and videos. There's Torch audio, text, and also Rexis for recommend systems. And they essentially do the same thing for these other data modalities, or rather, Tonic does the same thing as Torch vision. It makes it easy to download datasets with a single line of Python. It will, if you don't have this dataset on disk, it will download it automatically, and then the next time you execute that line, it will realize, or it will check that you have this dataset already on your disk, so it doesn't need to re-download it. So that will be a very fast, it will be fast to execute. And as we said, it provides a standardized format, so that we always get the same output regardless of the datasets. Then Torch Vision allows, like Tonic, allows for data transformations and augmentations. So the difference between transformations and augmentations is, so augmentations are a subset of transformations that are typically stochastic. So that means that you apply in a stochastic manner. So a transformation might be, I want to convert these raw events to a different representation, such as time surfaces, for example, or a voxel grid. And then an augmentation, you might want to include in your dataset pipeline, but you might not always want to apply it, right? Because so let's say with a given percentage, I want to flip. Typically, a classic one is like flip the image, like at the 50% chance. Or we might want to crop images or events. And so Tonic does everything and takes care of everything in the raw event space. So it provides lots of transformations and augmentations that act directly on the raw events. Once you convert it to something like an image-like representation, you can just use the Torch Vision transforms and augmentations. So for example, if you convert a bunch of events to a time surface, then it looks like an image, and then you can just use your Torch random crop augmentations afterwards. So it's really, the goal is not to reinvent anything that's being taken care of by other libraries. So we can chain essentially different transformations. The Tonic ones take care of the event format, and then Torch Vision ones take care of the image-like ones. And then the important bit is that when we create such a pipeline, everything is wrapped in a data loader that is hopefully parallel and fast. So that means while you are transforming some kind of data in memory, another thread, another process is started that already loads the next sample from disk, and that way you don't, you can load data as fast as possible on your GPU, because the data loading is really often the bottleneck for fast machine learning pipelines to train your model faster. The GPU is often not the bottleneck. So you will see, if you look at your GPU utilization score, you want to get that as high as possible. And if it's not, then it's likely because you're reading the data slowly. or there's some expensive transformations in them. I'm going to show you a bit of code of Tonic just in a bit. I'm just, setting the stage, so to speak. I think where does Tonic go? I think we can see that event-based vision is picking up quickly. So, the number of publications each year grows, like in major computer vision conferences. So this is definitely a domain that's growing. So we can see, next to data and audio and images, I think that events is becoming also this new interesting modality for people to play with. And you can already see it now in some public datasets. In multimodal datasets, they do include event-based camera data as well. So yeah, it's really cool. We can see that nowadays some, let's say, implementations of papers, people still write their own data loaders sometimes, and because they want to make it as efficient as possible. And I think if we can free up that time that researchers spend on just mangling the data into the right format, I think that's for the benefit of everyone. So if we can, at least fix this first data part and provide a good solution for that hopefully is used by more people, then I think research in that field overall can also accelerate, much like with the use of torch vision. Personally, I have moved a bit away from neuromorphics because I've moved into robotics. So it is currently not a focus at the moment, although I think there is good use for it later on also in robotics. It's just that I'm dealing with much more basic problems for the moment, just like how to make the robot go straight in a line. It turns out to be a very difficult problem, which I hadn't anticipated, but it's okay. I'm getting there. I think that what we see in machine learning is, these trends for really large models that can generalize well, and for that you need access to huge data sets, all the data sets actually, ideally. And if someone knows has that power to access all the data sets, and if you work with such a library, then you will know how to funnel all of these data sets and combine them. I think that will be really helpful in order to train first, foundation model in event-based vision. I really think that because the alternative is for you to do all the data conversion yourself, and that is a pain. So I would say let's just work together as a community. Everyone, people have already started adding their own data sets, and so whoever knows how to use such a library, I think they would have an advantage in that sense. And lastly, I think if we as a community can also show that there is this equivalent of torch vision for events, then who knows, maybe it becomes a torch events library one day. It's certainly already very focused towards PyTorch. It is written in a way that we could also add different backends, let's say for JAX, for example, or whatever people are interested in. And but for the moment, it is geared towards PyTorch, although the largest backend is still a plain NumPy backend. So what does it need in order to, like, where are the kind of like maybe pain points at the moment. So I think that still what people would like to see is some really simple data loading pipelines. That means it's not just a data set, it's not just the transforms, but it's really the end-to-end thing of much like if people feel like maybe lightning modules. So it provides you with, you just have a few parameters, and you just click, dataset.next, and it will give you a batched version, a batched sample, sorry, that you need. So maybe I think for the moment we provided kind of like all the different modules that people can play with, but maybe for some people that's not so interesting to dive in, because they just want to have something super simple to work with. And so some high level data loading pipelines, I think, would be great. The thing with event-based data is that it gets a bit more complicated than loading images, because you don't typically load a whole event-based recording into memory and then just feed that to your model, because it's a video, right? So you will need to slice it in some way, and so that has to happen ideally. You want to compute it once, and then so how you slice it and how you aggregate events makes it a little bit more tricky than just working with images. So that also brings me to the next point, where for the classification data sets, your NMNIST and your speech commands data sets that are the spiking speech commands, for example, like any event streams that are there for classification, where you have an event stream and a label. Those are pretty straightforward. They are also not very big typically, but where it gets more tricky are the multimodal data sets. So for anything about object detection, for optical flow, there's larger data sets out there that provide, for example, images and IMU and events and all sorts of modalities. And if you then need to think about how you slice and dice that data in a way that is that makes sense, and that such that data is aligned and that is still fast, is actually not so easy. So I think currently there are these modules, these building blocks implemented in Tonic, but I think what would help a lot if we could provide such really end-to-end data loading pipelines, and that way people will have a much easier time using those data sets. And lastly, I think reference implementations to load data sets, but also maybe how to train a simple model would be great as well. So if anyone is thinking about diving deeper into playing with Tonic, I think those would be points worth exploring. Okay, so now I am going to just open the documentation. So this is the documentation page for Tonic. I'm just gonna walk you a bit through what's in there. So I will start with the datasets. So we have here a list of datasets. Most of them are for event stream classification. So that includes both visual and audio classification. So these are typical, just like stream and label. But I think more interesting ones are, or let's say more complex ones, are things like DSEC or the TU Munich robotic dataset. And there's, MVSEC is also a popular one for optical flow benchmarks. And then there's one for eye tracking, for example. There's one for star tracking. And so I think people kept adding new datasets over time. And so these are the datasets that are currently implemented. And then we have the transforms. That's the gallery. So we have the representations that transform the raw events into image-like representations. So for example, you have your voxel grid, your time surface, where you can see that this decays, so all the events look fainter. Then this image just bins everything to just one image. Binary representations and frames is a 2D histogram at a certain frequency. And then we have also, so these are the representations, and then there's transformations that we can apply, some of them stochastically as augmentations. And then you can see, how we can downsample, or how we can flip left, right, up, down, or add noise, or remove events. There's all sorts of things. I think that, there's some interesting augmentations still to be explored. I think what most people do today is they just they convert it to something like a voxel grid or a time surface, and then they mostly use image augmentations, which works pretty well, I think. I think it depends on what you want to do. If you have an event-based processor, then maybe you want to do the augmentations more in the event space. If you're working on a GPU, frame-based augmentation is totally fine. Okay, then we have the tutorials. I have a few tutorials in there. I'm gonna actually go through them in VS Code just in a bit. And I wrote a bit of FAQs and some background stories, and I added some of that as well. I think as for the API, so there's, I think, the largest part are the transformations, but you have here all the implemented datasets. Let's see if we can show the source code as well. Okay. Maybe, okay. It's at the end of the day, these like implemented datasets are really not that complicated, because it depends on the dataset, I guess. But there's a lot of redundancy that you can reuse from dataset to dataset. So it's not the trick to add one. Okay, then we have there's also audio transforms on events. And let me see, there's a functional. So this here is just like the different implementations in NumPy, for example, for the different transforms. And okay. I think now I'm gonna jump to the tutorial actually.
Great. Can I just interject here for 1 second? Because you say it's easy to add the data sets, but isn't it fair to say that it's easy because you provided all the functionality, right? You basically, like you said, provided a uniform way to treat these event-based data sets. So with the transform, for instance, it's very easy to get the right representation you need.
That's right.
There's maybe 2 steps to adding the data set. One thing is to curating it in the right format.
Yes.
But then also to having all the transformations available, so it's easy for people when they use it to either use time surfaces or voxel grids or whatever else, as you said. Is that fair to say?
I think what I wanted to emphasize here is that it's easy to because this dataset class here is basically this taking care of this, mangling it into the Tonic framework, right? Tonic way of standard. And even this one here is not that many lines of code, because you have some helper functions that exist in Tonic. And then once you have it converted into the Tonic standard format, so let's say structured NumPy, and then this like
data
NumPy
type.
data, exactly. Then exactly as you're saying, then everything else downstream falls into place. Exactly.
So that's quite extraordinary, right? I think also for the audience to realize that if you then have a neuromorphic data set, it's significantly easier to publicize it, right? Make it available for others to use compared to if Tonic was not there, right? So
yeah,
super nice. And then the code is a good example, right? You can really see it's well documented, so you know what to copy or steal or however.
exactly.
Yeah, cool. I just wanted to emphasize that. Thanks.
No, thank you. Of course. Okay, cool. Let's have a look at some examples. So I'm switching over to cursor here. So this is literally the tutorial that's in the documentation, but I thought might be worth just going over it bit by bit. So how that looks like is you really have like a one-liner that says, where do you save the data to? In this case, there's just a training or a test set, so it's just a binary flag. And I just downloaded this data set earlier, so if I execute this line, then it will just return instantly because it realizes that it was already downloaded. And then I can add some transforms to this. So here I add, for example, a random crop. What is a bit specific about the event-based transformations is that you need to sometimes tell it what are the boundaries of the event-based recording, because just because there are no events in a certain location doesn't mean that the sensor size, that the pixel doesn't exist. So that's why you have to say what is the sensor size of this recording in order to kind of like give it the frame such that when it flips it, for example, or in this case crop, such that it knows the boundaries, because it might be a recording with just very few events. Okay, so that's a bit specific. So that's why sometimes this sensor size parameter shows up. So we can add here multiple transformations, and we can feed that. Or now what we're going to do is we're just going to load the raw data. So let's say let's have a look at data in its raw format. So this here now is a structured NumPy array, and here we can see so this is x, y time step in microseconds, and then a binary flag that just says on or off event. So that's the data, and then we can apply, and then we have also the label. So in this case, it's a 0. Okay. And we can now, let's say, just transform the data manually. Now I'm going to execute this. And we have here some helper function that just says, okay, given the raw events, which, is hard to say what that really means, because, this one can't really tell much from that unless you really go over every event. So we're just going to use this helper function that plots and transforms these events into a frame and then plots them on a grid. So if I transform this again, no, this will be as a random crop. So let's see if it changes. No, the seed is set, I think. Oh no, it does. Yeah. Okay. So that's a simple example of how you would define a transform. And then what you can do is you can actually define this transform here and provide that transform there. So dataset now obviously is not still gonna work because I loaded it. Okay, so now we're gonna have, for example, here cropped data, and now I cropped it twice. Amazing. So let's see, we have crop data here, and now I need to say crop data. There you go. So now I defined the transform as part of the dataset, and then I can, it's going to do all the transform under the hood, and then when I load a sampler, it's just going to be that data that is already transformed. Okay, that's one thing. Let's have, is there a question? No. Let's have a look at.
There's no question, but maybe maybe we just point out, like, now that you have the label and the data, right? So
Yeah.
anyone who is familiar with machine learning will know that's exactly what you need, right? So this is literally, like, with this transform and this data loading, that's literally all you need to train your model.
That's right. Exactly.
Right. So it's a very nice thing. And what are you writing here? Like 5 lines of code?
Exactly. That's exactly
pretty sweet.
5 lines of code.
Yeah. No questions so far. I'll jump in if there are any, but please also for the audience, there's quite a few people streaming now, which is fantastic. Please don't hesitate to ask questions. Now is the chance to interrogate Gregor for his expertise.
I want this to be very interactive, and I'm just gonna go through these tutorials, and so if people have questions how to use it, and I'm also curious to hear a bit like the challenges that you guys faced, like because when I wrote this library, so I kind of know how to use it sometimes, but I'm curious to hear where the difficulties really for people, because I know especially around like slicing, for example, caching, like we're going to look at it in a bit, can be sometimes a bit tricky. So yeah, please don't hesitate to ask questions.
So it's good we brought that point, because already now we have a couple of questions actually. Do you have time for that, Gregor?
Of course, yes.
So what Tarek asks whether the dataset is loaded lazily. So you pointed out that these things are very big, right? They're movies, right? So it can be many megabytes. Do you load them lazily, or how does that work?
Yes, so that needs to, exactly. So you need to load them lazily, because otherwise, unless you have really a tiny data set, then so how it works in this standard data set, where in the standard case where you really just load a whole recording, you provide an index, right? And then it will just go, it will first, when you create a data set, it will have a list of all the file names, and those will be, correspond to an index of the data set. And then when you say dataset 0, it will just go and fetch that file and load it. Yeah, that's right.
There's a second question briefly. Justin asks, how was the name of Tonic selected? Where does that come from? Like, why Tonic?
I just thought it sounded very good.
It is pretty cool.
Actually, you know how it came? No, I know. Like, I remember now, because there's a thing called tonic spiking, actually, for muscles. If you have a muscle tone, and it just constantly fires events, and so I felt like tonic is this like just continuous stream of events. So it's a bit like tonic muscle firing.
And I love the dual meaning. Like, you can both doing it tonic, and you can have like tonic dataset event firing.
And I like
very
tonics.
cool.
I mean, live in London, so yeah, it's also good.
I'll step aside for now and let you continue, Gregor, but I'll probably be back with a few more questions.
Sure. I'm happy to answer questions. Really, like, keep it coming. So what I want to show now is I added now a different transform. So for example, this is called two frames. This is really just taking a bunch of events, slicing them. There's different ways to slice it, but in the simplest case, we we take a time window of x microseconds. So this is now time windows of 1 millisecond, and we just add them up, and we create a 2D histogram, really. Like so, it's what you add 1 millisecond worth of events and add them up into an image, and so then you have multiple of these images. So let's see if we now hold on. So here I need to say sensor size is whatever the original sensor size is. I think it's like 32 times 32. Then we crop it down to 16 times 16. So now I also need to say the new sensor size for this transform here will be 1616 and 2 polarities. The time window is now, that I can choose depending on the application. So let's say it's just, let's make it 10 milliseconds. And now I'm going to load the first sample, and I'm just going to load the data. And so let's have a look at the shape. No, that's because I didn't load the data. It's always exciting to do live coding. Okay, so what happens here? So we have, so if we have, so this data set is 300 milliseconds worth of data. So we chose samples of 10 millisecond slices. So that's why we have 30 10 millisecond samples, right? So this first one is the time or batch dimension. And then we have 2 polarities. So this is essentially channels, and then height and width. So this is now our image-like representation. So we can now also change this, and we can say, for example, so it's been a while that I've done this, so bear with me. Let's try this. We're gonna import Torch Vision as well. Let's hope I don't regret this. And then I'm gonna add a Torch Vision transform here. See, if it blows up, of course it blows up. We have 4 dimensions. Okay, no, that doesn't work. Okay, now what I wanted to do is actually an augmentation. So let's say a random crop here. And let's do this one. Let's see if that works. Also doesn't work. Okay, we need a pill image. All right, so you can see I really should have tried this a bit before, but okay, getting there. So I think, can I do to pill image? Let's see if that works. Also not. Okay. So typically you can, okay, it's because we have the time dimension as well. That's why it doesn't like it. So if I were to select, I don't know, 1 second, let's say, then it still has the time dimension. But in theory, like, we can then chain like Tonic and Torch like that. And yeah, so now what you would need to do is you need to select maybe the right one, or you basically provide or you choose a crop function or a Torch Vision function that works on that format, on that 4D format, which should be the case, really. A bit surprised, actually, because this is just a batched image format. But okay, that's how it is at the moment. And let's have a look at a dataset that includes images and events. So I also just earlier downloaded this dataset. This is from a Davis camera. So you have here both events, I'm you, and images. Yeah. So these are just plotting here the timestamps. Okay, so then here we compare for the images, for example. So you can see here I get back now I get back a dictionary of or a list in this case of the actual data. So now it's just not just one piece of data. And now I just want to show that if we wanted to apply the same transform to the event frames and the gray level images at the same time, so we have to make a bit of a helper function. So, okay, so this is actually what I needed. So here we have the Davis data sensor size. We have our the mean difference between images and events. And here we're going to manually feed this data transform to actually transform events and the frames separately. So the frame transform is this one here. So that means we're going to turn events into images, and then the frames, so that the real RGB images, sorry, are going to be cropped. Like that. But both the RGB ones and the event frames are going to be cropped. So if I just run everything here, we're going to supply this like custom data transform function here. And at the end, we're going to have one event frame that is a random crop, and that same random crop is applied to the gray level image, right? Let's see if, I don't know, maybe there's a seed set here. Oh no, sorry, it's just a center crop, it's not a random crop. Let's do random crop. Okay, then that's why it doesn't work, because I'm applying it here 2 times. Okay, all right. Let's keep it as a center crop. All right. Yeah, so that is just to say that how using custom functions we can transform data, multiple data that are part of one sampler in a data set, right? So I could add another transformation for IMU, for example, if I needed to, slice it in a specific way. Okay.
Let me just jump in here quickly, Greg, if you don't mind.
Yeah.
So I think that's very cool, first of all, also that you can intermix PyTorch and
Yes.
and Tonic transforms and essentially custom functions. There are a few questions, if you don't mind.
Yes.
So one is by Alessandro, who's asking, how are Tonic datasets stored? So before we talked about the caching and the live loading, essentially, but do they also have the same format? So if I wanted to add a dataset, what format does it have to be stored in?
So essentially, you as a dataset or owner choose your own dataset. So like Tonic supports loading H5 datasets, NumPy, ROSBAGs. I don't know. If you wanted to do it in text, probably we could do that as well. So my advice to new dataset owners, if you're going to record your own dataset, is to use a H5. That's a really good format that is compatible with NumPy and that supports compression. That's probably the most efficient. Yeah, but then so what you write in Tonic is the converter that says, here's my data in whatever format, and if a user wants sample X, then here's how I fetch that data and load it, and then how I present it to the user. Exactly. So in Tonic, then once it's in Python, then it's all in the same format. I hope that makes sense.
Very nice. Otherwise, like keep the question coming. There's another question which asks which encoding scheme the transform class is using, and then maybe that refers to all the different types of encoding, because I guess there are many, you can do many possible encodings, right? I mean, you mentioned something like voxel grids and
Yes,
these exponential decaying things. So
indeed,
how do you,
indeed.
yeah, how does that work?
So at the end of the day, you can provide, if you implement, for example, your own representation transform, then you can just do that. There's many out there. I see new ones coming up in papers every now and then that combine, for example, like different modalities. The ones that are currently implemented are the voxel grid and the time surface and binary representation and the 2D histogram. So these are, I would say, very common ones. But if you wanted to use something else, then it would be a relatively, you could implement a paper, for example, that would be also a helpful contribution, and add that.
Perfect, thanks. There's one maybe brief question we can take, because we've been talking a bit about encoding. And someone here is asking what to do on FPGAs, Gregor. Do you have any advice? Like, let's say we want to run our SNNs on an FPGA. What kind of encoding would you choose?
Okay, so now we're getting into, I'm training on my custom, I want to run inference on my custom neuromorphic chip. What do I do in simulation or during training? So if you have an FPGA, you can choose any representation that you like, right? So I think that is highly dependent on what you want to achieve. If you want to process event by event, because your input is like very few events and you want to have a very low latency, then you can, and you have an algorithm that does, I don't know, optical flow using plane fitting, which works on an event by event basis, then you don't need to convert anything to frame-based representation. If you want to use GPU accelerated machine learning, you will have to convert to some form of tensor. And for that, I think something like a voxel grid or a time surface are the most common ones. Yeah.
Thanks. Let's leave it there. I'll step aside again, Gregor, and let you continue. Yeah. Thanks.
So basically, I just found out what was wrong. Let's say the conversion between Tonic NumPy output and Torch is just to pipe it through the Torch tensor constructor, and then you can reuse all the Torch vision transforms, and that's it, right? So here, when what enters this compose transform function is events, and out comes something like frames. It gets converted into a tensor, and then we apply the random crop. And then we can see that what comes out here with a time window of 10 milliseconds is 30 slices of two polarities and 16 by 16 size, width, and height. I think that at this point, I showed what I wanted to show in terms of basic principles. Yeah, we can look at slicing. I'm not sure if it's so interesting. I don't know how people feel about it.
Maybe just briefly explaining the concept, but I think, Gregor, you also you talked a bit about maintenance and what's
exactly. Yeah,
exactly.
It'll
also be fun to touch upon.
Yeah, no, you're right. It's a good point. Okay, let's briefly explain the concept of slicing. as I said earlier, an event recording is like a video, and some of these recordings are very long, like hours long. So they're quite big files. So you cannot load them into memory, certainly not onto GPU memory at once. So what you want is kind of like breaking up a video, an RGB video, into individual frames or just a few frames. We also want to slice such event stream recordings into subfiles, and therefore we have different ways of doing that. I would say, the standard way to do that is just slicing based on time, but you could also slice on by number of events, for example. There's different ways to do it. And if you just slice a recording based on time, then what Tonic will do, it will wrap an existing data set, and it will calculate where are the indices of events at these like time intersections, and it will spit out a new data set that now has many more samples. So the original data set here, NMNIST test set, had 10,000 samples, but once I slice this data set into something smaller than the original 300 milliseconds, so let's say 50 microseconds, sorry, no, 50 milliseconds, sorry, then the number of samples in the new sliced version of this data set grows sixfold, because now I have all these smaller samples, right? And that is, not ideal, just slicing it, because for the moment, what I'm only doing is storing the indices. And then when I want to retrieve a specific samples, I still have to load the whole recording and cut out the sample and then retrieve that. So then there's ways how you can, rewrite this whole new slice data set onto disk, and then you really have your new sub sliced data set as individual files. So that's where caching comes into play now. But I think these concepts are explained in this tutorial, which is which is online. So in the documentation, in tutorials, you can go to dataset slicing, for example, and then you can literally go through exactly this tutorial that I just showed you. The other ones are there as well, for example, for the Davis one, and more for example, multimodal data sets. In regarding maintenance, I think, I want this. I just would find it sad if this project would die like that. So I think if anyone is willing to look after it, by all means, you can do what you feel is right, and as the community evolves, also the needs a bit for these libraries change a bit. So I'm more than happy to assist with help and support what to implement and how. Maybe I think there's a bunch of pull requests that need to be dealt with, mostly making sure that it runs on the latest Python versions, Torch versions, that the testing pipeline is up to date. And yeah, I think that's mostly it. Obviously, then if people feel like it and want to add more data sets, that'd be great as well. But I think, and just answering questions, because I see, for example, on the Neuromorphs chat, there's also a Tonic channel actually, and people ask questions on there. So I think it's being used. Maybe some things are not clear and I don't know about them. So if so let me know what's been challenging for you, and what's been easy so far?
That's a great point, right? And I think, I mean, there's been a lot of effort put into this, and it's very certain. I can say that because it definitely helped me generate a lot of value. So Tonic has been really valuable for the community. I want to get back to the maintaining a little bit, Gregor, but I'm curious to know. I mean, you mentioned some of the things that needs to happen, like taking care of the pull request, making sure that it's compatible with newer version of Python, and so on and so forth. I guess it's also something interesting with the handle of the global interlock and maybe some parallelization stuff there. But putting that aside, like given for instance that you've chose to build this on NumPy, which I think is a very versatile choice. Right? It means you can. It's basically the only dependency as far as I see, apart from PyTorch.
Yeah.
How do you see that interplay? Like, do you think Tonic should stay with a NumPy foundation? Should it break free from PyTorch? What should Tonic do in the future? Where do you see the tech heading?
I think so. When I started to write it, it was not really clear whether TensorFlow or PyTorch was going to make it. So that's why we just decided to keep everything in NumPy. I think maybe nowadays, if someone was to write it from scratch, maybe it could just go full PyTorch. I think that would make sense. As I said, there's you can add different backends. Probably, nowadays all that it needs is just one extra line. That is the Torch tensor constructor, which is like very cheap to execute because it does, it references the data in memory actually, and so I think, let's say that one works and is well tested so far. So I would say is not the most critical point to refactor, but if people would want to double down on PyTorch, I would be be happy to see that as well.
I mean, now it seems like it does support PyTorch, right? So you do have everything there. The only difference, I guess, would be that all the transformations happen in PyTorch rather than in NumPy. Yeah,
that's right.
But it's very cool. It's very cool how versatile it is because it doesn't have to be only PyTorch. And I've seen, for instance, a lot of Jack's transformations of the Google library also using PyTorch-ish datasets. And they're basing their stuff on NumPy. So I guess Tonic would be very well compatible with that.
I think so. Yes,
kind of workflow.
I agree. I think the benefit you get from having the Torch tensor is that you can move it to the GPU, and then you can just do your operations on the GPU, which for some things is very helpful. But NumPy is also very fast, and then if you load files in parallel and do things on the CPU, it's fine, honestly. I think maybe like some general trends I would say is that definitely we can see just in machine learning the trends towards multimodal huge data sets. So people are not really interested in MNIST anymore, right? So that's why what I show you it was basically to introduce you to the concepts, but if you then have the multimodal data, then it gets a bit more complex. And that's why I said that if we can provide something that wraps all of that, right? Even just have literally just a one-liner especially for the more complex data sets with a few parameters, and have a bit of reduced degrees of freedom, but hopefully most people will be fine with some defaults. And I think that would be very helpful, and because maybe with this like slicing and caching business, in the end, maybe people still found it a bit tricky to use.
I mean, to be fair, it is tricky. It's a hard problem because you're shuffling so much memory.
Yes.
So,
exactly.
Like, I want to ask you a brief question then regarding the Tonic direction. So, what do you think is the next challenge for Tonic? I mean, now we've talked about these issues. We talked about maybe the PyTorch, but what what do you think Tonic should guide for in the future? What is the most important problems regarding, for instance, neuromorphic dataset that you think Tonic could interact with?
Sure. The most important problems that, can you repeat that, the last part?
Yes, I'm just wondering, like, if there's going to be a future maintainer, for instance, coming over and swooping in and solving problems, like what should be the main things to focus? What should they prioritize, essentially?
Yeah. So I think making sure that all the tests work, and because sometimes for dataset owners, they they choose to not host the dataset in the same place anymore, or something like that. And so just to make sure that everything still works when you want to download the dataset, essentially. Because there's some datasets, for example, the ASL dataset, I think, which is broken. So I just added just a few issues here. For example, yeah, the ASL dataset is broken. And then basically to have a bit, to look after the existing datasets and make sure that they're not broken. And yeah, I think that one is the most important, really. Making sure that, because I put into place actually a really large CI pipeline, and which is currently failing because of a silly error. But it tested on Ubuntu and Windows currently, and then it will automatically push it the latest documentation, the latest code coverage, and it will even publish it. So that's all
Nice.
set up. So people don't just currently just have to make sure that the tests are passing.
But I think it's valuable that most of the effort is there, right? And let me just say for the ones
it's
listening
not
here,
missing
I think
much,
it's
honestly.
Yeah, and it's a wonderful experience. So for the ones listening here, I think it's a great chance to learn more about neuromorphics and dataset handling by building some of these components, right? So it's a wonderful experience, and it's really nice of you to also want to help out, Gregor, in the sidelines.
Sure. No, of course. No, I think
yeah. Sorry, go ahead.
Yeah, I think one it's really the crucial bit about event-based cameras, especially, is that the data is different, right? So if you understand the data well, then you get you have an advantage, and you can maybe think about different algorithms as well.
Yeah. No, exactly, and not just understanding it well, but also handling it well, right? Especially with the memory constraints and the bandwidth constraints on existing platforms.
Gonna close this failed test tab.
I mean, that's how open source development goes, right? It would be weird if you didn't have any loose ends. Gregor, there's one final question, if you have time for it.
Yeah, definitely.
So Tarek asks whether Tonic is suitable for real-time processing. So if you have an event camera, directly plug it in and then do filtering transforms on the fly. Is Tonic a good place to do that?
So that Tonic is not built for. So you can. So there's other libraries that Jens particularly authored, such as AEstream and Fairy, that are geared towards that. So Tonic is really made more for machine learning pipelines. So anything that is on disk, and how to shuffle it efficiently, between the different memories, CPU and GPU, and disk. So I think if you want something real-time streaming, then you better look at AEstream or at Fairy. Let's have a look.
Thanks for the shout. I mean, actually, if you don't mind, I wanted to share that as well. But if you can find the Open Neuromorphic website and open the mission board, Gregor, I can show you something in Explore Resources to the left there, and the Key Challenges mission board to the right. Because now we've been talking about maintainers, but you also pointed out that Tonic is part of a wider ecosystem, right? So all these bits and pieces need to fit together. And I think Tonic is fantastic because there are so many libraries like SNN Torch or Jax SNN or Norse or whatever that takes the data sets and work with it in Tonic, right? And it kind of coexists because the value of the simulation libraries increases when there's something like Tonic. So all these pieces fit together. And if you scroll down, we are trying to list all the key challenges that we in the Open Neuromorphic community sees for the different projects.
Nice.
So what I just want to highlight is that Tonic is also in here. So for the ones listening here, if you're interested in these kind of things and believe neuromorphic technology is important, check this out, and you can see some of the issues that Gregor mentioned, and maybe also understand how it fits together in the ecosystem. So that's maybe one entryway to plug into the ecosystem, look at the issues. Otherwise, I guess, Gregor, you're going to be around on the Open Neuromorphic channel and
For sure, definitely.
And help out or comment if needed.
Yeah, definitely. No, it's a really cool, great work that you guys are doing here. I like it.
Thanks. Shout out to Justin for building most of this. It's really an amazing team we've assembled. Thanks to all of your work as well, Gregor. We are running out of questions and also of time. Gregor, is there anything you wanna end with?
I think the field is really growing. If you're like a PhD student or whatever, like you just want to tinker with event-based stuff, I think playing with these sort of libraries, I think, is a great way to dive into it. And if you understand it well, and you then understand how to train your models fast and efficiently, you get an edge because you can then do it much faster than other people. I would say that's definitely a benefit.
Beautiful words, Gregor. Thank you so much for taking the time. Thank you so much for all your effort, and thank you for being a part of the community. Much appreciated.
Thank you. Cool. Thanks for the time. See ya.